Today I'll be talking about continuous delivery of the Cloudfoundry platform. A little bit about myself. I'm Tushar. I work on the cloud operations team at Pivotal, which manages Pivotal web services. So why should, a quick show of hands, how many of you are application developers in the room? How many of you are operators or have deployed Cloudfoundry in some setup? All right, so the reason why we should care about continuously delivering the platform which runs your applications is primarily the value from maintaining infrastructure within a business is going away. You have all the big giants, Google, Microsoft, Amazon, and even VMware in the private space, taking up infrastructure and providing it to you as a commodity. And soon that's going to happen with the platform. You don't want to be building your own platform. You don't want to be writing your own platform. You just want to use whatever is already commoditized. The real business value lies in applications. That's one of the reasons why your platform needs to continuously update itself and always be able to update whenever new patches are available. So the top 3 lessons that we learned as a team was humans are error prone and computer programs are testable. I'm going to dive deeper into this in a bit. The other thing was, given room for failure, your team will achieve great things. Part of the reason is this software has exponential payoffs. You build software today and you can reap the benefits really fast, and then you can build more software on top of it to reap more benefits. And it's not about continuous integration or continuous delivery or whatever you want to call it. The process is more about continuous improvement within your team, and CI and CD are just a means to get to that end. So what is continuous delivery? I look at continuous delivery of the platform as flying an airplane. The reason I say that is because autopilot is awesome, but to be safe, you need humans. You ideally want your platform to always keep updating itself, patch itself. You don't want to be involved in the nitty-gritties of managing your platform. But if you're running thousands of production applications on them, which affect business directly, you don't want to make mistakes as well. So it's good to have some amount of control, but you don't want to be controlling every bit and piece that gets into it. So quickly, what is Pivotal Web Services? Pivotal Web Services runs the latest OSS Cloudfoundry. It's also a test bed for the PCF services marketplace. We run Apps Manager on PWS. So if you've signed up on Run Pivotal.io for a demo at any point of time, you see the Apps Manager UI. We have real customers. We have thousands of applications deployed on Pivotal Web Services, and we are multi-tenant. So given all these conditions, if you decide to continuously update a platform, there are a lot of side effects that can happen and can affect your business in a direct way. So as a cloud operations team, our goal in terms of, as a team, is high predictability. And I think that's a goal that any operations team should value. Because you want to, for example, you want to run an application which requires Python 2.6 support. The way you do this in a traditional system, you'll do apt-get install Python. You might get Python 3. You might get some other version of Python. The way you control that as an operator is you either download the tarball, compile it, or you do apt-cache search, do some ugly grep awk, pick up the right package name, and say, I want exactly this thing. So predictability is one very important thing that an operator wants. And that sometimes disallows the operator to take risks of automating and having the ability to have the payoffs of automation. So the reality of cloud operations is there is low predictability because there are so many moving parts, especially given the amount of abstraction the application runs on. An example is your Cloudfoundry application runs in a container which is running on a Diego cell, which is running on some infrastructure. And it talks to a lot of other components in the process of being healthy and alive. So there are a lot of moving parts, just like the airplane. But you want to know you want to have control over a lot of them. So what does the Cloudfoundry CI/CD experience currently look like? If you're an application developer, it's CF push. We change code, CF push, change code, CF push. It's quite an awesome experience. You can also do blue-green deploys by writing some nifty bash around it. But what about the operator? What does the operator have to do? Does he do bosh deploy? He presses the ops manager deploy button. But what about the properties? Am I missing any properties? If there are new properties, what are the side effects of them? Will customer apps experience some kind of slowness? I should be aware because the support folks will be behind me and tell me, hey, these customers are complaining about something. And you should at least be aware that what's happening and what did you deploy. Because the Cloudfoundry release is pretty big and pretty complex at this point in time. So understanding every change is hard, but you need to understand what customer impacting changes are present. How we have delivered production Cloudfoundry in the past and currently. The first one is checklists, the good plain old checklists. You have a bunch of text. Did you do this? Did you do this? Did you do this? It's pretty long, can get really horrifying. The other is GoCD, which is a CI system provided by ThoughtWorks. And last but not the least, Concourse. So I'll be sharing some of the learnings that we've had through our journey on trying to continuously deliver Cloudfoundry in a production setup. So this is what one of the checklists looks like. And we have like code blocks so that we know exactly what commands are we typing, and we know the side effects of them, so that if you have to revert, we know what to revert to. So checklists have the pros of easy to understand for a new team member. When I joined my team, I could follow the checklist and deploy Cloudfoundry to production within like 2 weeks. That was pretty awesome. But checklists are also very verbose, so they can explain that, hey, you're doing this step, you should be able to, this is why you need to do this. You don't have to do this. You can ask this other team member if there is a problem. But checklists are really, really frustrating because you need to maintain a lot of state in your head. You need to know where you are at. You need to keep clicking the checkbox right now or after you do something. And sometimes you might forget to do that, and then you might just you might repeat the step, and it's just a lot of waste of time. So checklists have high human processing time. Sometimes you need to communicate with other teams. If they're not providing you artifacts, you need to go and ask them, hey, what version should we deploy? And what is the other compatible version of this other dependency that you have that needs to go out? And last but not the least, people forget to update checklists. You create a checklist, it becomes stale pretty fast. So an example is, for example, I decide that I installed a web application and it fails to install because it doesn't have the right version of Python there. So as a person who's aware of that, I will go ahead and change it. But when a new team member comes, he probably doesn't know that this requires a different version of Python. And you end up forgetting to update the checklist. So checklists give you a high sense of predictability. Why I say high sense of predictability is because it's still very hard to predict what's happening. And they're really low on automation. So some of the decisions that we took to move towards GoCD from a checklist were to automate boring, predictable, and obvious parts from the checklist. Some of the things were pretty easy, trivial to automate, and we wanted to get rid of using the checklist for that. We wanted to reduce the time spent on deploying and updating the platform and services. So a usual BOSH deployment, which has services, is pretty similar across multiple services. So once you build one pipeline to continuously update, let's say MySQL, you can use the same pipeline to update Redis. And also, it added the ability to consume artifacts from other teams. So other teams were also using GoCD, so they would publish an artifact that here is a tarball that you can consume and deploy Cloudfoundry. This is a screenshot of how some parts of GoCD look like. Some of the pros of GoCD are scripting logic can live in code. And being an operations team, you are usually downstream to a lot of teams, especially if a lot of Cloudfoundry development is happening within your company. There are at least 10 to 12 teams when we started using GoCD who were upstream to us in terms of what goes into CF release. So it's very important that you should have the ability to consume artifacts from different teams. What are the challenges of GoCD? There's too much clicking involved. At some point, as a programmer at heart, you don't want to click. You want to type instead. It became challenging because once you create a pipeline for, let's say, the MySQL service, replicating it is really hard because either you have to find the pipeline in a really huge, non-humanly readable XML file, or you have to click 10, 12 buttons and copy-paste 10, 12 different blobs of code. It's also hard to reuse work of other teams. An example is the open source CF release team generates a pipeline to deploy Cloudfoundry to a particular BOSH director. And you, as an operations team, want the ability to look at what their pipeline does, do large parts of that, and add whatever little bit you want to add for your particular team. And that was really hard with GoCD. So GoCD gives you a higher sense of predictability compared to checklists. Why I still say higher sense of predictability? Because there are so many things in GoCD, like it has too many options that clicking everywhere, sometimes you can get confused, where did I last click and where do I need to click next to change this one thing. But it also provides higher automation than checklists. Moving to concourse. So why did we, as a team, decide to move to concourse? As I said, the UI is really hard to add a new. If you wanted to add a new task to your workflow, you had to at least click 3 times and figure out where exactly do you need to place this particular task. And then, is it in the right order? Will it be executed here or will it be executed somewhere else? And just the complexity of doing a simple thing was really annoying. Continuing talking about some of the hard things with the UI. Concourse runs tasks in containers, so it avoids corruption of your build directory or your build server. So as soon as your task is executed, your container dies, it's very ephemeral in nature and it's very isolated in nature. So Concourse has some of those good capabilities. One of the major reasons was Concourse provided first-class primitives for talking to a BOSH director and deploying Cloudfoundry applications. So if any of you have tried deploying a Cloudfoundry application with Concourse, it's really, really easy. It's like 4 lines of YAML. And that was like another major reason. So this is what our production deployment looks like for Concourse. The reason you see a more vertical picture rather than a horizontal picture is because it gives us control. Like each of those boxes provide artifacts that are consumed by each one of the other boxes. And that allows us fine-grained control. So if our deployment process got stuck at uploading the release and you just need to deploy again, you just run the deploy task. It can directly consume the artifact. You don't need to rerun the entire pipeline. So Concourse, the pros are YAML pipelines. YAML is good and bad, depends on how long it gets. It allowed us to reuse pipelines and tasks from other teams. So Concourse has this amazing thing of writing custom resources, which an example is a Slack notification resource. So if your team is on Slack, somebody in another office wrote a Slack notification resource. You can just reuse it, and you just put a Slack message there, and it can send a Slack message to your Slack channel using your API key. And it's very easy to build these new kinds of resources and reuse work of other teams. The ability to version pipelines. Since your YAML is hopefully nice and small, you can version it, and you can see diffs across how my pipeline has evolved over the last couple of weeks, months. And containerized tasks. So one important thing, as I already mentioned, is Concourse runs different tasks in containers. So your build environment never gets polluted with external things, and it might not accidentally run other things. And this is very important if you're doing something in a production system. What are some of the cons of starting Concourse? We started trying it out in alpha stage. So it was going through active development. So some primitives within our pipelines needed modification ever so often. Maintaining a Concourse server sometimes can be non-trivial. And the other thing is, since Concourse is very new team members found it really hard to understand this new CI system and the different workflows that we're already using. So in that case, pairing helped a lot within our team. So the verdict on Concourse is there is high predictability and high automation, but you need to make sure that your team can maintain the Concourse server and make sure that you're running Concourse in the right way. The overall wins. The overall wins for us as a team was easy CI/CD replication for new IaaSes. So we currently run Pivotal Web Services on AWS. And we were trying Azure, for example. And we could just reuse our pipelines that we use for AWS in our Azure setup. And now you're continuously deploying, say, Redis, MySQL, in different environments. And this is a completely new IaaS, a completely new Cloudfoundry installation. And as Pivotal has started working towards shipping these pipelines to customers directly so that on your Cloudfoundry installations, you can continuously update stuff with a pipeline. And we ship you the pipeline. This is really powerful because as a platform operator, you don't want to be manually doing things. If you get a well-tested product, the pipeline as a product from your customer, from your vendor, you can directly go and be happy about automatic updates to things like stem cells and other things within the ecosystem. Also, it has lowered the time to onboard a new team that needs to deploy to production. So an example is if there is another service for, you have a new Cassandra service that wants to deploy to production, you can say, hey, this is a pipeline, how we deploy Redis to production, tweak it, do whatever you want, and just apply it to our Concourse, and it'll just work. So I'll just reiterate the top 3 lessons that we learned. Humans are error-prone, and computer programs are testable. So we saw that in checklists, the more state you put in a human mind, it's harder and harder for the human mind to navigate through that complex state machine. Computer programs are designed to do that. They do it well, and they can be tested in smaller units. Again, given room for failure, your team will achieve great things. So it was not an easy task to convince team members which were already happy with, hey, we are already deploying to production with a checklist. It takes a whole day. It's fine. But over time, since we were allowed to fail and allowed to iterate effectively over our CI/CD setup, we migrated to GoCD first, and we struggled with some of its UI. And we still were able to continue to deploy Cloudfoundry in a continuous manner. And last but not the least, continuous improvement of the team is the goal and not CI/CD. I like to repeat this because when you look at people telling you, hey, you should CI your thing, you should continuously deliver your thing, that's just not what you should buy. You should buy the fact that you want to continuously improve your team. And CI and CD is a way to do that. And it allows you, it frees your mind up from doing manual tasks of clicking buttons and being error prone. So what are the things you can do as individuals? Allow room for failure within your culture and take baby steps. It's not very easy to start learning a new CI system from scratch, pick up, deploy Cloudfoundry from scratch using a new CI system. It can get hard, but take small steps, understand the basic primitives, understand why something is in a particular way. And there is a lot of, the other good thing about Concourse is a lot of pipelines are open source. So the way you deploy Cloudfoundry release, there are open source pipelines available. So you can take them, have a look at them, tweak them to your needs. One thing a colleague of mine had mentioned was, you should test your CI and CD scripts. They are testable. You should test them. And work towards standardizing technology and not the people. So this, I talk about this because at Pivotal, we standardized GoCD first within the Cloudfoundry team, and everybody was using GoCD. So it was really easy if you have a problem to approach someone, and they'll tell you, hey, this is how you solve it. Or ask at stand-up, hey, we are having this problem with GoCD. How do we resolve it? And same thing with Concourse. Even though Concourse was alpha and really hard to manage, you have colleagues who can help you out with figuring out those issues, which take a lot of time if you're trying to do it alone, and you spend hours without any results. And that's Word. Any questions? Yep. Pardon?
You mentioned a redeploy or update box within CI. Is that box the underlying part of CI? Yeah.
Bosh is the thing that deploys CF. I'm not clearly understanding your question. If you can. What? What is Bosh? Oops. Are you asking what is Bosh? Yeah, so Bosh is basically this tool which deploys Cloudfoundry. And it's a tool which packages so basically the problems of predictability, right? Bosh solves a lot of the problems of predictability. You provide it a manifest. You tell, here is the tarball, here is a checksum of that tarball, and get it for me from, Bosh will do things like, it will fetch it from the right S3 bucket. It will also know how to set up the networking within your cluster. It will also do further things about networking. And now, in the newer version of Bosh, you can also specify all the networking and everything for your entire infrastructure upfront. And each software release, like Cloudfoundry, for example, will be able to use that global networking configuration. Any other questions? That's it. Thank you.